Hi everyone. In this video what I'd like us to practice is determining the relationship between two different molecules. So we learned in class that molecules can either be completely different molecules or they can be something called isomers. Isomers are in general molecules which have the same molecular formula but they're still somehow different. There are a variety of different types of isomers that we've learned about. Really the big distinction that we've drawn is something called a constitutional isomer, which means that the molecules are hooked up in a different way, or a stereoisomer, where all the atoms in a molecule have the same connectivity, but the different parts of the molecule are projected differently in space. And so what I'd like to practice is taking a variety of different pairings of molecules and trying to determine the relationship between these two molecules. Are they isomers? And if so, what type of isomers? To do this, I'm going to have a little bit of help from our isomer flowchart, which is on Blackboard. So I'd recommend that you go print this out before trying this. But when you do that, give it a try and follow along. And again, if you feel pretty confident in doing this, what I'd recommend is you first look at the pairing, pause the video, give it a try for yourself, and then press play to see if you've done it correctly. Okay? I'll give you guys a chance to do that. So this first difference here is we're looking at these two cyclic molecules. Okay, so the first question we have to ask ourselves is, do they have the same molecular formula? And in this case, this winds up being C5, as a 4-membered ring, plus a methyl group, and then 2, 4, 6, 7, 8, 9, 10. Okay? Over here, it turns out that this has the exact same molecular formula. C5H10. And so this means that these molecules are indeed isomers. And so in the first step of our flowchart, what we have to ask is, do the pair of molecules have the same connectivity? Are the atoms connected in the same way? And we can see here that no, they're not. First of all, this one only has a 3-membered ring and an ethyl group poking out, whereas this guy over here has a 4-membered or cyclobutane ring with a methyl group pointed out. So according to our flowchart, the fact that they are not having the same connectivity suggests that these are constitutional isomers. Okay, that being said, let's move on to the next one. We've got these two molecules here. 1,1-bromochloroethane. Okay, so the first question we have to ask ourselves is, does this molecule have the same connectivity? Are the atoms, let me go back a step. Do they have the same molecular formula? By the fact that I jumped ahead a little bit, you can probably guess, yes indeed they do. Both of them have 2 carbons, 4 hydrogens, a bromine, and a chlorine. But what we have to ask ourselves is, okay, are they connected in the same way? And in this case, absolutely. 1 carbon is bound to a hydrogen, a bromine, and a chlorine. 1 carbon is bound to a hydrogen, a bromine, and a chlorine. And so really the question we now have to ask ourselves is, what type of stereoisomers are they? And so the first thing we're going to do is we're going to ask ourselves on this section of our flowchart, do these pair of isomers differ across a rigid plane? And remember, the rigid planes we've seen in class thus far have been either rings or double bonds. The fact that these guys don't possess either a ring or a double bond strongly indicates that, okay, these guys aren't geometric isomers. So under the heading of non-geometric isomers on our flowchart, we can ask ourselves, are the pair of molecules mirror images of each other? And so there's a few different ways we can do this. The first way is we can rotate the molecules such that we can tell if they're mirror images of each other. But I think perhaps a little bit more of a foolproof way of doing this is actually examining our chiral center, or the thing that's going to make these guys stereoisomers, or chiral in that case, and ask ourselves, are they of the same chirality? Are they both R, both S, or is one R and one S? And so let's go ahead and assign that very quickly. So first, identify the chiral center. Now we establish our priority. Bromine is 1, chlorine is 2, the methyl group is 3, and the hydrogen is 4. we then have to rotate the molecule such that our hydrogen, or our lowest priority atom, is at the back. And so I'm just going to twirl the molecule a little bit like an umbrella to go ahead and do that. And so what this will look like is the following. So our hydrogen is going to go back. It's going to go back. Bromine is going to come forward. And chlorine then is going to come into the plane of the board. And so with that in mind, so 1, 2, 3, 4, we can make the distinction that this molecule here is of S stereochemistry, because it's a counterclockwise motion in our rotation. So let's go ahead and do the exact same thing for this molecule here. Again, chiral center, priorities, bromine is still 1, chlorine is 2, methyl group is 3, the hydrogen is 4. And again, what we're going to do is we're going to twirl the molecule like an umbrella, such that I'm able to put our lowest priority group, in this case the hydrogen, back into the plane of the board. So I'm going to go ahead and do that. Hydrogen goes back, bromine comes in the plane of the board, and our chlorine is now coming out of the board at us. And so you can see in general, now that we've had these in the same orientation where both the hydrogen is going back into the board, they're certainly non-superimposable. But let's go ahead and finish our assignment here. In that, okay, hydrogen is still 4, 1, 2, 3. And let's take a look at the following. So when we establish whether this is RS, put our pen at 1, we can see in this case we're rotating clockwise, which winds up being R. So when two molecules have one chiral center, or one carbon bound to 4 different things, and one is S and one is R, we consider these to be non-superimposable mirror images, or enantiomers. So, again, going back to our flow chart, we were originally at non-geometric isomers, and so we've asked ourselves, are these pair of isomers mirror images? And we can say yes in this case. They are mirror images of each other, but they're non-superimposable, so that leads us to enantiomers. Okay, so with that in mind, let's get to the last example here, and let's ask ourselves, first of all, does this molecule, are these two molecules actually isomers? Do they have the same molecular formula? And you can see by the fact that both of them have a cyclohexane ring, a methyl group substituent, and a bromine substituent, we can say that, yeah, they are indeed having the same molecular formula. The next question we have to ask ourselves is, what is their connectivity? Are they connected in the same way? And it turns out, absolutely. The carbons are in a ring, 6-membered ring, with a methyl substituent on both sides, and a bromine on both of these guys. So we can determine then that these are indeed stereoisomers. Now we have to ask ourselves, do these isomers differ across a rigid plane? Yeah, they wind up definitely differing across a rigid plane in this case. Remember, in the case of a cycloalkane ring, or a ring in general in chemistry, the ring, which I'm going to highlight in sort of this plane here, is our rigid plane. Things can either point into the board, away from you, and they can't rotate around because of the ring, or they can come out of the board at you. And we can see that if we denote our cyclohexane ring as our rigid plane, the difference here is that our isomer on your left, the one I'm pointing to right here, is in the cis conformation. Both the methyl group and the bromine are pointing both back into the board, whereas on the right isomer here, the methyl group is coming forward, whereas the bromine is going back. Because they differ across this rigid plane, we can assign these as geometric isomers. Right there. So hopefully this helps in your studying and determining the relationship between two different types of isomers. Happy studying. See you soon.